All right, so here we go. Promise this one's going to be shorter today. Since we've got most of the trig part done, now we're just going to do the inverse of trig. So previously, when we were using the trig ratios, we used them to find the missing side lengths in right triangles. All right, but today what we're going to do is that we will use the inverse of trig function. Okay, the inverse of the trig functions, and what we're going to do is we're going to be able to find the missing acute angles. So we're going to find missing angles today instead of sides of course, a right triangle. So the inverse of these functions are the inverse of sine, and anything, you raise it to the -1 power, it's going to be inverse. So cosine to the -1, that's the inverse, and then tangent. And again, this is all done in your calculator. So these functions can be found on your calculator by pressing the second button, all right, and then the trig function. So for instance, if you're going to look for an angle of a right triangle instead of a side, what you're going to do is you're going to set up your ratio, and then you're going to hit second and then the trig function button. So whichever one you want, or if you're doing sine or cosine and so forth and so on, or if you're doing tangent. And when you hit that second button and then the trig function, you're going to see the little -1 exponent, which means you're using the inverse. So let's look here. When we did this yesterday, when we were finding missing sides, let's just say we're going to find PQ. What we did was we used the angle, and then we used the side that we wanted and the side that was given. We set up our ratio. Since we have opposite and hypotenuse, that's going to be the sine function of the angle is equal to the opposite over the hypotenuse. And then we solved with proportions, and we cross-multiplied. So now we know that we cross-multiply, and we always make sure that our calculator is in degree mode before we do any of this. And so the 18 sine of 33 is going to give us 9.8. So that side PQ is 9.8. So that's how you find missing side lengths using trig. Now what we're going to do to find missing angles. So let's just find here the measure of angle P. So we want to know what that measure is. So again, we still have to use this angle. Remember, you're always going to use what's given and what you want are things that you use. Again, still we want this angle, so we're going to label. All right, this is the opposite leg, this is the adjacent leg. Now that sets us up for tangent. So watch. What happens over here is we put sine and then we put the angle measurement. So this is sine of 33 degrees. Well, when we're looking for angles, this is what we don't have. So we don't have the angle measurement. And remember, we use an X to represent anything we don't have. The rest is the same. Equals the opposite leg. In this case, that's given as 12. The adjacent leg is given, which is 7. So what I wanted you to see are both of these ratios. All right, these ratios and proportions. So there's one, and here's the other one. So basically, the setup is all the same. Your X is just traveling to different places. So when your X is with the trig, you have to take the inverse. And I kind of just used the little saying that if your X is on the inside of the triangle, so you see like this is basically our X, it's inside the triangle. Well, if it's inside, if X is inside, then you're going to have to use the inverse. So I just try to kind of connect those words together because they both start with in. So X is inside, you need to take the inverse. So to put this in your calculator, you're going to hit second button, then the tangent button, and then what's going to pop up in your calculator is the inverse of tangent. And then all you're going to do is divide out this ratio. Remember, a ratio is just a fraction. A fraction is basically just two numbers that can be divided by one another, that will be divided. So this is, we're going to put in 12 divided by 7. That's why we practice setting up those ratios, is because you have to use it for the inverse trig. So this is what gets put into your calculator. That's how to look on your screen. Okay, so let's set these up again. We're going to solve for the missing angles. So just pick one of them, A or C. It doesn't really matter which one. Let's just do A first. All right, so we use this angle because that's what we want. What was given is the opposite and the adjacent. So that is tangent of the angle is equal to the opposite over the adjacent. Okay, so I'm going to go ahead and do this one for you, and then we will, let's just set that up, and then we will do it in class. We'll finish this. So in your calculator, you're going to hit second tan. This is going to pop up, and then you're going to divide out your fraction, and we'll do that when we get into class. We'll finish that up. And we'll find the measure of angle A. Once we find the measure of angle A here, you see what's going to happen is now we have a triangle, and we're going to have measure of angle A, and we already know that B is 90. So these two angles are complementary. So once we find A, all we have to do to find C is just take 90 minus the measure of angle A, and that's going to give us the measure of angle C. Same thing over here. We're going to find this angle. We're going to use what we want, use what is given. So adjacent leg and hypotenuse, so cosine of the angle is the adjacent leg over the hypotenuse. And again, like I said, we'll finish that in class. Okay, next again is word problems. And remember, your optional major grade project is over word problems and drawing pictures and solving them correctly. So number 3 here says find the missing angle and side measures of triangle ABC. Given that measure of angle A is 50 degrees, measure of angle C is 90 degrees, and side CB is 16. So again, we've always got to draw ourselves a picture. If no picture's given, that's our first step. What we need to be careful about here is they want measure of angle C to be 90. So this needs to be C, and we'll just go BA. Okay, again, the A and B could be in either position. C must be the 90. All right, they give us that the measure of angle A is 50 degrees. We have to find all the missing angles. Well, then how much is the measure of angle B? All you got to do is do 90 minus 50. Okay, and we get 40 degrees is the measure of angle B, because everything inside of a triangle always adds up to 180. See, that's never, ever going to go away. All right, CB is 16 here. They want us to also find all the missing sides. So just pick one of the sides that you want to find first. It doesn't matter which one. Let's just say, okay, I want to find the length of AB. So I'm going to use angle 50 that was given. This is my opposite leg. This is my hypotenuse. So O and H is sine. So sine of the angle is equal to the opposite over the hypotenuse. Oops, that needs to be an X, doesn't it? There we go. Okay, we're going to cross multiply and solve this. So we have X times the sine of 50 is equal to 16. So divide by sine 50, divide by sine 50. So X equals, and I'll go ahead and do that for you since we did this already in class. So this is 20.9. So side AB is 20.9. Now we have a couple of different options here, because now you know that this side is 20.9 and this side is 16. We still need to find side AC. So you have two options. You can do trig again to find AC, or if you like Pythagorean theorem better, then you can do Pythagorean theorem because you have your hypotenuse and a leg. So you can square this, subtract this squared, and so forth and so on. Since I'm already, in the trig mood, I'm going to go ahead and just do trig again, and I'm going to look for now the adjacent leg. So I'm going to use the opposite and the adjacent. All right, so that's going to be opposite and adjacent is tangent of the angle. The opposite leg here is 16 over the adjacent is what I want. So again, we're going to Now that is 13.4. So now we have all the missing angles because we have C is 90, A is 50, B is 40. Side CB is 16, side AB is 20.9, and side AC is 13.4. Hey, can you check your answer for reasonability? You sure can. So watch. This triangle, what we just figured out, that's 90, this is 50, this is 40. We figured out the side lengths. This is 16, this is 20.9, and this one is 13.4. So check for reasonability. What do we know about sides and angles? Remember, they grow and they shrink together. The hypotenuse should always be the longest side. Is it? Is that what your calculations told you, that the hypotenuse is the longest? It is. Good job. Next, we know that the bigger the angle, then the longer the side. So here's your largest angle. Is this leg longer than the other one? Yes, it is. So your measurements are probably correct because they're reasonable. So if you come out with something like if this measurement was bigger than 16, you did something wrong because it needs to be less than 16 because it's across from the 40. All right. So here, let's draw a picture. A meteorologist measures the signal from the ground to a weather balloon to be 1503 meters. So we have a meteorologist. Meteorologist. He's going to measure the signal from the ground up to a weather balloon to be 1503 meters. The balloon is 986 meters above the ground. What is the angle of elevation? Oh, there's that AOE again, angle of elevation. Remember again, that is from the ground, your line of sight up to an object. So angle of elevation is from the ground up. So they want to know, what is that angle in there? What is your angle of elevation? So x is on the inside. If x is on the inside, we do the inverse. So we're going to use this angle because that's what we want. We're going to use this leg and this one because they're given. So we have the opposite in the hypotenuse, which is sine. So sine, I'm missing the angle, is equal to opposite over hypotenuse. So there you go again. We'll just set that up and we will calculate the inverses when we get to class. So that's how you would set it up. Let's go to the next one. A road is 1.6 kilometers long. All right, so we have a road. It's 1.6 kilometers long. It's rising 0.4. And it wants to know, okay, then what is the angle of elevation of the road? So we have our road, it's rising, so it's really like a hill, basically. So again, we need this angle, we need it given. So that sine of the angle is equal to the opposite over the hypotenuse. That's the setup for inverse of trig. And like I said, we'll finish the calculations when we get back to class. Have a good night.